Now suppose we take the limit of this particular function. This particular function, of course, it looks like it's approaching the 0.53, but then when we plug in, we get 5, and on the other side, it looks like it's approaching 5. So if we ask what's the limit as x approaches 5 of this function, it turns out that this limit is undefined. This limit does not exist. We cannot give a single value and say we know that the function looks like it's approaching this single value. However, we can do something else. We can talk about a one-sided limit. And we talk about one-sided limits often when we have this kind of discontinuity. Incidentally, this is called a jump discontinuity for obvious reasons. It looks like the function is heading toward 5,3 and then it just jumps to 5,5 and continues on its merry way. So this is a jump discontinuity, and we can talk about this in terms of a one-sided limit. A one-sided limit is when we approach from just the left or just the right. Well, if we're approaching from the left, we're approaching from the negative side. And so the way we would write this is the limit as x approaches 5, and then we'd put a little negative sign there. And then the way we read this is to say the limit as f of x as x approaches 5 from the left. And of course, as we can see in the diagram, this limit is going to equal 3. The limit of f of x as x approaches 5 from the right, denoting that with a little plus sign, is going to equal 5. And so the two one-sided limits are not equal. In order for the limit to exist, in order for limit as x approaches c of f of x to exist, it must be true that if we take the one-sided limits, that they are equal to each other. So if the one-sided limits are equal, then we can talk about the overall limit existing. If the one-sided limits are not equal, as is the case when you have a jump discontinuity, then overall the limit is undefined at that point.